go. Today is going to be dedicated to making sure everyone is ready for the test that is this week. As a reminder, everything I'm about to say was written in the email that I sent out earlier this week. But just as a refresher, the test will be given to you online and you will take it outside of class. So we'll take that. They're not having it on the lab this week. To begin your test, once you are ready, you will send me an email informing me that you are ready, and then I will send you your test document, and you will have 5 hours to complete a 1-hour assignment. The extra time is partially to account for academic accommodations, partially to account for who knows what will come up when you are in your own space taking the test, bathroom breaks, food breaks, interruptions, and also to account for the fact it's going to take you longer than normal to get answers to questions that you email me. I will be checking my emails the entire time, but I know that there is a little bit of lag there that would not exist normally. So, the test is designed to take you 1 hour. You'll have up to 5.
Does it look like the study guide you sent us?
It does look like a study guide. That is an excellent question.
So like same questions, different numbers?
Not exactly. The study guide questions are good analogs, like the types of things on the study guide will be similar on the actual test, but the questions themselves won't be carbon copies with different numbers. Yes?
I know it was in the email, but when do we have to have it sent to you by?
So if I say you tell me you're ready and then I send you the test at 7 p.m. You would need to have your answers and your work to be by 5 hours after that point, which would be midnight.
With like what day?
Oh, thank you. Midnight next Monday. That way, everyone will have taken the test by Monday. We can talk about stuff from it in lecture on Tuesday, and then begin chapter 5. So, you can begin at any time leading up until midnight on Monday. I do recommend starting within normal operating hours, because if you email me at midnight someday that you want to start, I'm going to bed. I'll send it to you, but you won't be able to ask me that many questions, just depending on when I fall asleep. So I'm usually up till around midnight anyway, but just keep in mind, have this freedom, just, make sure you are, A, have a time slot and a space where you are okay for however long you need, and B, that the closer to daylight hours it is, the faster I'll get back to you on your question. And again, the last midnight on Monday, as Monday ends, Tuesday begins, is the end of the test, the end of the material. I don't want to give you anything brand new until that day, so today, and also, this class won't be tomorrow. Today will be entirely dedicated to review opportunities. I'm going to show you where I put some of the review information on the Brightspace page. We can talk about the list of topics on the test, talk about the test itself. You can ask any questions you have from chapters 1 through 4. There is one caveat, which I did attempt it. If my wording was confusing, I apologize. I attempted to mention in my earlier email, crossed the wires there. Presbyterian is currently giving out all of the flu shots to its insured employees today. And the only time I could get mine is during this class period. So in about 30 minutes or so, I'm going to announce a quick pause as I go upstairs to get that. Since today is entirely review, if you don't feel the need to be in this room getting the review, either now or during the optional study session during our normal lab time, you don't need to be here. If you feel comfortable with where you are, or you just want to email your questions and don't want to be in this room at all today, I understand. You can go. I don't want to force people to be physically here if they don't need to be physically here, given the whole quarantine thing. So in about 30 minutes, I'm gonna go upstairs, get that, rush back down, and then for however much time you guys want to stick around after that, we can continue review. There will also be a view session during our lab time. Again, that is optional, it's in place of lab. Some people might be coming in to actually start their test during that time. You don't have to be here for it, but it is a chance if you want it. Speaking of the study guide, my email earlier this week contained a list of practice questions. That document, where is my mouse cursor? My mouse is turned off, that explains it. So, this is the class Brightspace page. Scroll down to the Test 1 tab. So it's on the whole tab right after Chapter 4, all dedicated to Test 1. We have the formula sheet listed here. I'm currently making a more revised, better formatted formula sheet, which will go here. You can use that sheet on your test. I'll probably include it in the test document, so make sure you have a copy there. But you have your formulas. You don't have your notes, but you do have your formulas. You'll have every formula and constant you could possibly need. The revised copy will replace the old one here. You can come to the same place and get it. The actual practice questions are located right below that. I sent out a series of questions that are similar in both formatting and also question types, question content to what you'll see on the test. In general, when I make these sort of practice question sets, I tend to make this, like the practice stuff, longer and maybe a little harder than the test itself, because it is optional. You don't have to do it, but if you take the time to work through it, you have time to check your answers, it is very good practice. The test itself, whereas this is 9 math questions plus some short answer questions, the test itself is going to be 10 questions, all of varying lengths and difficulties. So you might start with a 5-pointer and then move on to a 10-pointer, 15-pointer, another 10-pointer. There's one 20-pointer, which I think is the biggest. Every question tells you how many points it is worth, and there is a total of 110 points worth of questions on the test. I am grading you out of 100 points, which means if you get everything right, you will have a 110 out of 100. So there's room for your bonus points. I used to have a system where I would give you like 6 questions and you'd only have to answer 5 of them, and then any extra work would become bonus points. But that necessitated every question be the same length and the same difficulty, which became really hard to calibrate. So doing it this way kind of lets you determine which questions end up being bonus ones. And you don't have to pick, it's just you accumulate points, any points over 100 gets you above 100. It's not written here on the practice test, but on the actual document for the test, after the question header, there will be an amount telling you how many points it is worth. And I again give out tons of partial credit for every single part of the question. If it's a 5-part question and you only answer 4 of the 5 parts, you will get credit for all the work in the 4 of the 5 parts. If you miss something or you just don't know what to do on one of the parts, you will still get points. So don't leave anything completely blank. The only way to get a 0 on anything is to leave it completely blank. Technically, any answer is better than no answer. The best thing to do if you're stumped is A, ask questions, B, start listing relevant formulas, because that will start jogging your thought process, and then start working things into those formulas, combining into the algebra. That is a surefire way to get some points on everything, even if you completely blank on torque as a concept. So these are good practice questions. The test will not be identical, but it will be similar. And each question will tend to combine various aspects into one question. For example, we have on this practice test, question 4 here, you're given the velocity of a car, the mass of it, the force the engine is exerting to drive it forwards, and then there's multiple parts of this question asking about different things you can calculate from those numbers. For example, we have net force on the car, identifying every force on the car, the kinetic energy the car has, because you can find that from the same information. What is the coefficient of kinetic friction based on what you determined earlier about the force of friction and the normal force? Power output. We find all of that information from just this same header, so I've combined the concepts into fewer questions so that ideally it's more streamlined and it's not a 20-question assignment. Write something for everything, even if it's a picture, even if it's just a formula, even if it's just a meme. Literally anything is better than nothing. In terms of the test itself. Man, I'm more scatterbrained than normal today. That's not a good sign. Put no water. Okay, I know what's going to be next. The answer key is down here. So this is a copy of the test of the practice questions, and this is its answer key. It appears to have been uploaded, rotated slightly. I'm sorry, but if you can download it in your PDF viewer, just flip it. I'm going to try to fix it this side as well. But the answers are all here, and since my handwriting is famously awful, I typed out the short answer ones for you.
Do we have short answers in the list?
Say again, sorry?
Do we have those questions, like where we have to write with no numbers?
These concept questions are more for the review sake. On the test itself, these concepts will assist you, but there's only one short answer question on the test itself. I will answer the question honestly, there's only one short answer question on the test. Additionally, in the interest of giving you information that will help you and not trying to trick you, I don't want to do that. In the actual, if you click on the actual Test 1 tab itself, this is all the information about the test. And this is the list of things that will be on the test. So this is pretty much, this list contains most of the things we've covered chapters 1 through 4. I have intentionally, and will tell you, I have already omitted from this list moment of inertia, and I also didn't put anything about rotational momentum on the test. So those aren't going to be, the formulas will still be on the formula sheet because they need to be. But if you're worried about moment of inertia, angular momentum, though there will not be questions about those on this test. Just to tell you that for the benefit of your studying. This list does have everything else we covered on it though, and again, it's just every concept from chapter 1 to 4, except those two from last week, because they're the hardest ones that I only barely glanced over, and I don't want to hold you accountable for that. And I like making these kinds of lists because I can just go through and mentally check off. I understand that and its formulas, I understand that and its formulas, so on and so forth. So, this list, practice questions, the key information on the test itself is all available to you. Again, did you have a question, sir?
No, I'm good.
It's okay. Every hand looks like someone's trying to get my attention, which is not your fault. It's my brain. We can open up the floor now to any specific questions you guys have about the test itself or about any of this stuff, chapters 1 through 4. If there's nothing specific you'd like to cover, I would like to go down this list with you all just as a refresher. But to give you guys the option of letting us focus on what you guys feel you need, do you guys have any specific questions, any specific topics you'd like to cover for today?
When we're emailing you about the test, how early ahead do we need to email you?
I would appreciate it if you got comfortable where you're going to take it, and then send me an email in that moment. I'm ready, and I will forward it to you as quickly as I get and respond to that email.
Yes, sir.
Granted, it might take me a second to respond, and you can tell me ahead of time, I will be starting at X time. Okay, yeah. If you know exactly when you want to start it, and you tell me that, I will send it to you at that time. Just to speed things up. You may sit down and email me saying, send it now. You can also email saying, send it at X time. So, did I say that clearly enough? Okay. Excellent question. Thank you. Anything else about the test or specific things from chapters 1 through 4? Okay. I know from when I've been studying things and in lectures when I was a student, I only ever think of my questions like long after the fact. So again, if anything comes up in your studying, let me know immediately and I'll get back to you. Yes.
Is there a answer key for this study yet?
Yes. If you'd like, I can email it to you directly, but I have also put it on the Brightspace page.
Oh,
And let me know if my handwriting is just too poor to be able to be read. Now, if you as an individual feel like you don't have any specific questions and that you feel comfortable where you are and you just want to study on your own, again, I'm not going to hold you to stay in this room today. What I plan on doing now is just stepping down that list one concept at a time, just as a quick refresher on everything. If that is not how you want to study, if you don't want to just go down this list with me again, you may go study on your own. But I will also be in this room during normal lab times. If you have a question and want to come back, again, that's optional as well. No need, no pressure. And as I go through this, please interrupt me with anything that any issues that come up as they pop into your head, about anything. I will admit, a lot of this list is kind of like there's a lot of items listed from chapter 1 stuff, because literally chapter 1 was a lot of interconnected things that stepped up one from the other to form the backbone of the whole course. So, from the very beginning, the first couple things we did were conversions and the metric scale. A specific conversion that I've had people reporting issues with recently is the conversion from radians per second to rotations per minute. So, just to give that as an example of a conversion really quickly, let's say you are given an angular velocity of 30 radians per second. This is again a measure of how fast something is rotating. Radians measure the same kind of thing as angles, it's just how much does it spin in a given amount of time. Radians per second and rotations per minute both measure the same kind of thing. They're both angular velocity measurements. So you can't convert directly from one to the other. If you have radians per second and you're trying to go to rotations per minute, first thing you want to do is cancel out radians and replace it with rotations. The conversion between those two things is here. 2 pi radians is 1 full rotation. When you complete 1 rotation, you have gone through 2 pi radians. That is the same as a full 360 degrees. All of these things are the same, they're just different units to describe the same thing. So, this is our conversion. We want to cancel out radians and replace it with rotations. Since radians is at the top, we want to cancel it by putting our conversion such that radians is on the bottom and rotations is on the top. Then, seconds to minutes. We want to cancel out seconds, 60 seconds in a minute. And that's going to leave us with rotations on the top and minutes on the bottom. So if you're going from rads per second to rotations per minute, you're going to multiply by 60 and divide by 2 pi. If you're going from rotations per minute into radians per second, you would reverse that. And so 30 rad per second is 286.48 rotations per minute. This, you could also call rotations per minute RPM, like the RPM gauge on most of our cars. I try to write it like this as a fraction, just to show what it is made of and how you would need to cancel things. But this is the same thing as RPM. If the question says RPM means rotations per minute, this fraction. We've been using metric units, so just understand what those units are, which ones our formulas take, meters, kilograms, newtons, etc. After that, our first formulas and concepts were about linear displacement, velocity, and acceleration. We sort of had a little review of that recently as we've been comparing them to their angular counterparts. The important thing to know there is the first 4 formulas we covered, the fantastic 4 equations. These ones here, these are the first 4 equations we covered. These all talk about the relationship between those 3 quantities. Of all formulas, these are some of the ones to know the best. Then, scalars versus vectors. Vectors have a direction, scalars do not. One-dimensional and two-dimensional motion. Most of our examples for the entire class have been one-dimensional, things just moving back and forth in a single axis. If something's moving two-dimensionally, it can move in multiple axes at once, and one of the best examples of that is projectile motion. If an object is a projectile, it is in a state of free fall. Free fall means an object is currently operating only under the force of gravity, and it is accelerating towards Earth's center at g equals -9.8 meters per second squared. And if I was to throw this marker into the air and let it travel that way, it would be moving in the x-axis and the y-axis at the same time. So our projectile motion questions are the best version of 2D motion that we have routinely done. Since I got a couple of projectile motion questions for people working on the practice test, just to quickly review that as sort of an example of 2D motion. Most of our projectile motion questions begin with some version of an object being launched horizontally from a high place. We've driven remote-controlled cars off of cliffs. We've kicked soccer balls off of roofs. Thing launched from high place. And again, the object is going to begin moving in two axes at once, the x and the y. Between those two axes, you do need to examine each axis separately. So you need to track the displacement of the object in both dimensions, which is why you need to do your formula twice, because you cannot mix axes together. Now, between the x and the y, in a projectile free fall question, which axis determines the time in which an object is in the air?
The y-axis?
The y-axis, very good. Because every object on Earth accelerates down at the same rate. It doesn't matter what kind of object you drop, they're all going to spend, as long as they start from the same height, it will take them the same amount of time to hit the ground. So it's the starting height that determines hang time, the time in the air. So if you have a projectile motion question, one of your first steps is you can use the vertical axis to determine the hang time. And within the vertical axis, if this object is launched horizontally, its initial y velocity is 0. Which means this term goes away, and the only thing making it move in the vertical axis is it accelerating because of gravity. This has the effect of giving it a certain amount of time from start to finish before it hits the ground. The higher you place it, the longer it has in the air. Now in the x-axis, if this object is again in free fall, is there any acceleration in the x-axis? No, which is why I've already crossed it out. Gravity is only vertical, it can't work horizontal on planet Earth. That means this ball is not accelerating in the x. This term is 0, which simplifies the formula to just this. As long as it's moving at constant velocity in the x-axis, the hang time determines how far it is able to go. Sorry, its initial x velocity determines how far it can go in the time it is allotted. If you kicked multiple soccer balls off of the same cliff, and the only difference is how fast you kicked them, the one kicked fastest will go farthest because it can go a further distance in the same amount of time. So the y-axis determines hang time, the x-axis determines how far it will go horizontally in that amount of time. That is why you need to look at both axes separately, and then the understanding from one will help the other. Next, force and Newton's laws, very interconnected topics. I am quickly going to pull up my answer key to the practice test. Because one of the questions I asked is, what are Newton's 3 laws of motion? So, first law is the law of inertia. All objects with mass want to keep doing what they're doing. If it's stationary, it wants to stay stationary. If it's moving, it wants to stay moving, unless something else forces it to change. The objects on my desk will stay that way unless something hits them. Objects flying through space will keep flying through space forever until something else hits them. Space is dangerous. The next law is just the formula force equals mass times acceleration. That is the definition of what force is. When you exert a force on a mass, it begins to accelerate. And then the third law is the action-reaction pair law. If you act on A, B will act back on you. These create third law pairs. And third law pairs have to act on two separate objects. If I push on board pushes on me. Those are two different objects being affected, which is why they don't cancel out. If two forces are acting on the same object, let's say we look at this card here, gravity is pulling it down, normal force from the table pushes it up. Those are both acting on this one object, which means they can't be a third law pair. The law pairs are always direct causal inverses on separate objects. Next was work and power, followed by different forms of energy. When you do work, you use energy to accomplish a task. You exert a force in a direction, you make something move in that direction, and you use up energy to do that. Power is how quickly you use that energy up. The more powerful you are, the more work you can do in the same amount of time. It also means you use up more energy in the same amount of time. Something to be aware of. The more powerful your device is, the more fuel it will chew through more quickly. Speaking of energy, we talked about its two different types. Kinetic energy is the energy of motion, and gravitational potential is energy stored in an object's ability to fall. Energy cannot be destroyed. It can change its type of energy, and it can change what possesses it, but you cannot completely eliminate it. It has to go somewhere and do something. For example, if I throw this marker straight up, I do work to give it energy. What type of energy does it have? Why does it leave my hand? Kinetic. I made it move. It has a velocity. It has kinetic energy. What happens to that kinetic energy as the marker rises? Very good. As the marker gets higher, its GPE is going to go up until it reaches its highest point, and its GPE will be at a maximum. It has stored energy in its ability to be falling. But at this highest point, what is its velocity? Or like if we freeze frame time right when it's at its peak.
0.
0. At that highest point, it has accelerated to 0. It will then begin accelerating down, but at that moment it's at 0, which means its kinetic energy is at 0. All of its KE turned into GPE, the energy converted from one form into the other. And then the reverse begins happening as it falls. The GPE turns back into KE as its height decreases and its velocity increases. So, can't be destroyed, can freely transform between different types. Then, momentum. Momentum is very similar to kinetic energy in that it is a thing mass possesses that informs it to be moving. The difference is momentum only has one form it can occupy. Energy can change states, but momentum is always momentum. As a result, it is always conserved in a collision because it has no other form it can occupy. It's always going to be there. Impulse is just change in momentum. If a mass's velocity changes, momentum has changed, it undergoes an impulse. This list is admittedly just a tiny bit out of order. I apologize for that. After that, we talked about the universal law of gravitation, the formula Fg equals gmm over r squared. That just tells you the gravity between any two things anywhere. Then we moved into rotation. Rotational motion for this list is just referring to rotational angular displacement, velocity, and acceleration as counterparts to linear displacement, velocity, and acceleration. What I want you to be able to do here is identify the angular counterparts to the Fantastic Four and the angular counterparts to those three concepts, be able to convert between them. Should I didn't put some triangle acceleration on this list. Yes.
I think the answer key on the first one is wrong.
Oh, did I make a mistake?
Well, I think the velocity I got was 43.5. It was double that. I think the answer was double that, so I was going to be right. Displacement over time, velocity.
It would not be.
So I thought it was 2 divided by 6. They only need 14.5 times.
Okay, so the formula that you're thinking about using was velocity equals displacement over time, which is a valid formula, just not for this particular question. That formula assumes constant velocity. Notice that, it's not, right. I am running out of board space, honestly. I have tried to indicate that in the way that the formula has been written. Notice it is just velocity equals delta x over delta t. It is not change in velocity, it's just constant velocity, a single number. This formula, your velocity cannot change. And in the practice test question 1, the velocity is changing. It is an acceleration type question. If it helps, for one thing, again, this is not delta v, it's just v. But additionally, this formula is actually equation 3 simplified. Notice that if the acceleration is 0, you have delta x equals velocity initial times time. You can divide both sides by time to get this. So this formula comes from equation 3 when a equals 0.
So I would just multiply time by the acceleration of velocity.
Correct. That is a completely reasonable mistake to make. You found the formula, it has the things in it you want. You have a velocity, so you would be displacing with time. That is just not the best one to use because of that caveat about the formula. That is a very good question. I want to address that now so that you don't make that mistake on the test. And I'm going to edit this list to take out rotational momentum and add in centripetal acceleration, because that's very important to know about because it affects your day-to-day life. When one object begins orbiting around some other point, be it a moon around the Earth or even your car turning along the street, there is some force pushing you to the center of a circle, and that force combined with your forward velocity is what causes you to move in a circular shape instead of in a straight line or to the center by itself. The main thing you want to know is just what the formula for centripetal acceleration is. It will be on your formula sheet, and know that you can find centripetal force by multiplying the mass times the centripetal acceleration. Again, that's going to replace this rotational momentum on this list. There won't be a moment of inertia or a rotational momentum question on the test. There will be centripetal force and acceleration. There is centripetal force and acceleration on the practice test, so again, if you can do the practice test, fine. Last concept that will be present is the idea of torque. Again, moment of inertia won't be on the test, so there is a formula for torque that involves moment of inertia. You won't be needing it. Instead, you'll be relying on the other formula for torque. That should be R. Radius times force. You exert a force at a distance from a fulcrum, you create a torque, and something begins spinning. You see this when you open a door, you see this when you play baseball and get something within that. So, know what torque is, namely be able to work seesaw type questions. We want to balance the torque on one side compared to the other. And that is all of the concepts that will be represented on the test. I am going to run out of here to get my flu shot shortly. Again, if you feel satisfied with where you are, you don't necessarily need to be here when I come back, but I will be back hopefully by 1, because that's when we said we'd be done by. Before I go, though, I want to assure you all that you are entirely capable of this. I know physics is kind of a big scary thing. It is literally classified as a hard science, but I've seen you guys, I've worked with you guys, I know that you can do this. I urge you to just remain calm. Remember to try every question. Leave nothing blank. Nothing breaks my heart more. And I want you to remember, if this information will help you to stay calm, it's why I'm presenting it to you. Tests on the syllabus say that, the syllabus says that a test will take up 40% of the total course grade. But there's going to be 2 tests, which means each one of those tests is 20% of your course grade. That means if you somehow got a 0 on this test, you could still get an 80 in this class. But none of you are going to get a 0 on this test because you're going to at least put an answer for everything and get some points. It's very easy to get a 50 on this test as long as you write formulas down for everything. Leave nothing blank. If you get a 50 on this test, you can still make a 90 in the class. I am saying this to you to remind you and give you empirical evidence that you're going to be fine. I'll be with you every step of the way. Breathe and stay hydrated, and email me with any questions you have. If you want to stick around to ask questions after I'm back from my flu shot, I will be coming back down the stairs right after that. But if you feel comfortable and I don't see you again the rest of this week, have a wonderful day. If you do want to stick around, I'll be right back. Thank you all very much. Let me just not burn out and off the camera.
Presentation.